All right, let's get started on the second day lecture of electron configuration, and we're going to apply some of the words that we learned to actual problems. What will the test look like? What will I need to know? How will I need to show you that I know what you're talking about? So this is actually, it's really crazy looking at first. However, don't get too nervous because it's actually one of the easiest things you'll do in chemistry, the upper level. So we have our goals today. I want you to be able to write electron configuration in the proper long form notation. I want you to be able to write orbital notations for certain elements in the proper notation. And I want you to be able to identify elements from their electron configuration or orbital notation. So orbital notation is basically electron configuration, but with like circles, and instead of representing electrons, they're going to be arrows. You'll see what I mean. Okay, so recall electron configuration is just basically the address of every electron in an atom. That's all it is. I'm going to teach you a way to kind of look at these elements as electrons, and the system becomes easy. Okay, so electrons fill the first energy level before the second and before the third. Within an energy level, S goes first. I taught you that in the last video. And remember, for a neutral atom, protons equals neutrons, and that equals atomic number. Okay, so we're going to write the electron configuration for hydrogen. So hydrogen is here. So remember, this is the S block, this is the D block, this is the P block, helium is over here, and this is the F block, okay? So we're writing electron configuration just for hydrogen, okay? So what we're going to do is write its energy level first, okay? So this is level 1, okay? That's the period number until you get to 3, and then it gets weird, okay? So I can't say it's the period number for everything because the D and F orbital, they actually skip up an energy level, and you'll see in a minute. But hydrogen, that's the easiest of them all, so we're going to say the energy level is 1. So for example, hydrogen, okay, it has 1, it's in the first energy level. It is in the, what block is this? It's in the S block, okay, so 1s. And then which, I don't know, group of that block is it in? And it's in the first group, so we're going to write it as 1s1, okay? And that's how you would do hydrogen, all right? It has 1 electron, so 1s1. So remember, this number represents the energy level, this number represents the letter represents the sublevel, and then this number represents the number of electrons in that sublevel, okay? And you'll see there's a pattern where you can say 1 and 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, and then 1 through 14. F is weird, but we'll talk about that later. Okay, so let's write the electron configuration for helium. So remember, guys, let's just go ahead and do it now. Helium is here. When we're talking about electron configuration, let's just ignore that it's over there by the P block. So helium is here. So it's still in the first energy level. Okay. So helium. Helium is in the first energy level. Its sublevel, this is the S block. So it's in the S block. And it has 1, 2. It has 2 electrons, okay? So 2 electrons. So helium has 2 electrons. It's in the first energy level, S block, and 2 electrons. Okay, let's do lithium. Lithium is here. So notice now we have to add another energy level. So here's where you might get confused. So the lithium, you must first do these before you go here. So it's basically here to here. So how you would do that is you have 1s2, okay? You don't do 1s1, 1s2. I see that common mistake all the time, okay? It's not 1s1, 1s2, 2s2. It's 1s2, okay? So that's full. So let's do lithium. Lithium. So you have 1s2, okay? And then you move on and you have, so there's nothing else in the first energy level, just these two. Second energy level, you have 2 So you just write next to it 2. And then this is the S block, okay? So 2s. And then how many electrons does it have in that second energy level? And that's one electron in that second energy level. So it's 2s1, okay? So that's how you would write it, 1s2, 2s1, okay? If you want to check after you have a bigger electron configuration, this is small, but you can check this, sorry, this and this should equal 3, okay, because lithium has 3 electrons, okay? Same with this one. Helium has 2 electrons, hydrogen has 1 electron, okay? So 1, 2, and 3. Okay, and the Aufbau principle, electrons enter sublevels with the lowest energy first. So that's why we went 1s2. So the second energy level, if you'll notice, second energy level has an S sublevel, and it has P sublevels. So that's why it goes the S sublevel first. It's the lowest in energy. This is where they want to be before there's a P orbital. It'll be way unstable if we had like 3 or 4 electrons all stuffed into an S sublevel that can only hold 2. So it is more stable to move to a P orbital once this is full, but you always start with here. So even though it's a second energy level, and remember there's an S and a P, it will always fill that S sublevel first. So that's basically the Aufbau principle. And you'll see that as a matching question in your test. All right, so nitrogen. Nitrogen is here, okay? So let's do nitrogen. Nitrogen, okay, has 7 electrons, okay? So 7 electrons. I know that because we assume it's neutral. It doesn't show, it didn't say nitrogen -3, okay? It didn't tell us it's an ion, so we just assume it's neutral. So it has 7 electrons. So we must first start with our first subunit, the first energy level. So the first energy level is 1s2, always, always, always 1s2, okay? So 1s2. Okay, we have 2 of the 7 electrons, and then there's nothing else on that first sublevel, so we need to, nothing else on the first energy level, so we move to the second energy level. We're basically reading like a book until we get to where we are supposed to be. So then we have 2s2. This is full, okay, so 2s1, 2s2, we say 2s2. 2s2, okay? Then we have 2, so this is still second sublevel, so 2, but this is not the S sublevel, right? This is the P block, so it's a P sublevel. So 2P, and then 2P, okay, and then 2P, 1, 2, 3. We just count until we find that element that we're going to. So 2P, 1, 2, 3. So the superscript is going to be 3. So this should be the electron configuration for nitrogen. Wow, I'm correct. I can't believe it. If you want to check yourself, you do 3 plus 2 is 5, plus 2, and that's 7. So we did it correctly. Let's do some more practice, okay? Magnesium. Okay, so for magnesium, which is here, okay? So now we're in the third energy level, okay? We still have to start from that first one, always. We always have to start from the first one. So we have 1s2, okay? 1s2. And then there's not a p orbital in that first energy level. So second energy level, we have a s and we have p's. So we have 2s2. Okay, so in that second energy level, we still have P blocks, so we need to add those. So it's 2P, 1, 2, 3, 4, 5, 6, so 2P6. And we're done with that second energy level. We're done with the second energy level. We're moving to the third energy level, okay? And we are trying to get to magnesium. So we have 3 is our energy level. So our energy level is 3, okay? And then, 3, and this is the S block, so 3S. So 3S, 1, 3s2, so it's 3s2. And that should be our answer, okay? And we are correct. So magnesium has 12 electrons. We can count them to make sure we have them right. So 2 plus 2 plus 2 is 6. 6 plus 6 is 12. We did it correctly, okay? So basically, no matter how far down you go on this periodic table, okay, no matter how far down you go, you always start from hydrogen, always. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay? So it's just, you always start, no matter what, you notice you always start from that 1s2. And then if it's after the 1s2, it's 2s2, okay? You notice there's a trend. All right. So for elements with more than 18 electrons, sublevels are filled out of order. So this is what I've been warning you about all year. So if you'll notice, this is up until like 3s, we've been super happy. We've been like, oh, this is easy. That's the number at the first. This is the number at the first. If we're on this period, this is the number at the first. Unfortunately, the d orbital is not compliant with that trend. It would be nice if it was, but it's not. So the d orbital actually starts with the third energy level. So kind of picture this whole block moving up one. So basically you go from magnesium to scandium on the third energy level, okay? So that's what it's talking about, that they're filled out of order. So you have 3s2. This is also the 3, but you this will be filled later, but you still will kind of go over here to the third energy level for the P. Sorry, give me a second. For the P block, and then you go back down to 4s2, and then you have 3d, okay? We're about to show you an example, okay? So this, I'm gonna kind of go quickly. So you have 1s1. If you'll look at the PowerPoint, I'll probably make it bigger on the screen. So 1s1, that's 1 electron. So you're about to see some orbital notation, and that's going to be in the form of electrons represented as arrows, and each sublevel, so like an s orbital or a p or a d, are represented by these circles, okay? So an electron is there, now 2, okay? And then once the 1s energy level is full, we move on to 2s, and then there's 2 electrons in there. Then we move on to 2p. There's 6 electrons in there. The order at which those arrows are entered are super important. You have to enter them that way. So here it's easy, 1 up, 1 down, okay? But look here. You see how you do 1 up on each circle before you can go down, okay? That's important. So the arrow's up here, down here. Remember, each arrow represents an electron. So here in the 3D, you'll see that it goes up, 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 and then down, 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 down. Okay? That's how it should be filled every time, because it's just in order of the stableness of the atom. It won't fill up a whole orbital and have empty ones. It's just not as stable. So it's all about how stable it is, the electrons are in it, and what electron numbers it has. For P, the electrons again, up, 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 and then down, down, down. In the 5s, it doesn't matter, 1 up, 1 down. And these are called spins. And we'll talk more about that in quantum numbers, okay? So I'm just going to kind of go a little more quickly here and fill in the orbitals. All right, moving on. So we have a good example now. We are in the 4th sublevel. We still won't include that D block yet, okay? But we'll do potassium. Okay, so potassium. Okay, so potassium is here. It's in the 4th energy level, and it's still, everything is happy with this one, okay? So it's 1s2, 2s2, 2p6, 3s2, 3p6, and then we'll do 4s1. So potassium We'll start always from hydrogen, 1s2, okay? 1s2. Next, we go down because there's nothing else in the p orbital. We have no p orbitals in the first energy level, okay? Second energy level, we have 2s2. And then 2p6, there's 6 of them. Okay, that's it. Okay, there's nothing else that we need to add for the second energy level. For the third energy level, we have 3s2. And then we have 3p6, okay? All right, we're done there. 4, we're on the fourth energy level, and there's potassium. So we have 4 S, we're in the S block, 4s, and has 1 electron in that S block, so 4s1. Okay, that's it. That's potassium's electron configuration, okay? Now, next one, we're going to do one in the D block, cobalt, okay? Cobalt's right here, right in the middle of the first D block. So here's the exception to all of the easiness. So in the first 3 rows, super easy, even 4s2, up to 4s2, it's easy, and then it kind of changes here, okay? So let's do cobalt. We'll do it in black because we haven't done black in a while. So cobalt. Cobalt is here. So we always remember start 1s2. So cobalt 1s2. And then 2s2, because there's nothing over here anymore in the first energy level for P. 2s2. 2s2. And then we jump over here to 2p6. Okay, and that's it for the second energy level. Then we have 3s2. We don't do the d orbital yet, okay? So 3s2 and then 3p6. Okay, 3p6, and then 4s2. Okay, and then last one. This starts with 3, okay? So 3d1, 2, so 3, we'll say 3, okay? This is that slide that said it goes out of order. This is what we're talking about. It goes back down to 3 because the d orbital starts with 3. You may want to make a note on your periodic table, whatever you want. 3d1, so this is the D block, 3d, and then we have 3d1, 2, 3, 4, 5, 6, 7. So 3d7. That's it. So the only weird thing that I was trying to warn you about all year is that that's it. So the D block just starts at 3 now, okay? The F block will do the same. It'll go 1 higher than the D block. Okay? If you wanted to check, cobalt, if you'll notice, has 27 electrons if it's neutral. 27. So if you wanted to add all of these up, I'm not going to do it because I'm sure I'll screw it up. So that's 12. I say I'm not going to do it, and I'm about to do it. So 12, 13, 14, 15, 16, 17, 18, 20, and then 27. So, okay, that wasn't so bad. Anyways, it has 27. We're good, okay? But this is that weird part that we were trying to warn you about. It just jumps back down when you do the d orbital, okay? Let's check and see. Oh, my gosh, I'm right. I can't believe it. All right, orbital notation. So basically, we're doing the same thing. So this, all of this that we did, that's called electron configuration. Okay, all of these that we just did, those are electron configurations, okay? Now we're going to move on to orbital notations. I'm just going to flip it upside down, okay? So now we're going to practice orbital notations. If I can spell. Ask Mike if I can spell. I can't, especially when I'm talking notations. Okay, so orbital notations, it's not like it's not right here on the screen. So basically we're just using circles to represent atomic orbitals, and then arrows will be represented by, electrons will be represented by arrows. So if there's one electron, you have one arrow in the circle. If there's two electrons, you have two, and we always start with the arrow pointing up first. So for example, we'll do hydrogen, okay? We'll start with hydrogen again. So hydrogen. So remember hydrogen here, its electron configuration was 1s, there's an S block 1, okay? So hydrogen was 1s1, and then for each energy level, you have like a set of circles, okay? So you'll have one circle for the S, okay? And then this right here, this number represents how many arrows go in that circle, okay? So this is one arrow, it gets pointed up, okay? So that's what hydrogen looks like, okay? It's 1s1, okay? Well, just give the answer. Lithium, okay? Lithium, remember, lithium was 1s2, 2s1, okay? So lithium's was 1s2, okay, because we had to include the whole thing, 1s2, and then 2s1, that's the electron configuration. So for every one of these, so s orbitals, or s energy, not energy, s sublevels, they have one circle, okay? They have one circle. P's have 3s, D's have 5, F's have 7. We'll do some more examples. So lithium, it has 2. So in this energy sublevel, you'll have 2 electrons. So 1, 2. Okay. This is another sublevel, but it only has 1 electron in it. So you have an arrow pointed up, and that's it. So that's the orbital notation of lithium. Next, okay, yeah. So the Pauli principle, it just says that 2 electrons at most can fit in these circles, and they must have opposite spins. So it has to be, if you ever have like 2 up arrows, you've done something wrong, or you have 2 down arrows, you have to have 1 up and then 1 down. That's all it's saying. Okay, so for example, I really didn't want to show you the answer. But let's just do nitrogen. We know the example is nitrogen. We'll do nitrogen next. Okay, so nitrogen is here, okay? It's in the second energy level and the P sublevel. So you have, in the first energy level, you have just an S, so 1s2. This should be like getting repetitious to you. I am so sorry. Hold on, I screwed that up. This is not 2. Okay. Okay, sorry. 1s2, that's the first energy level. Okay, so 1s2, and then we go to 2s2. And then we stay in the second energy level and do our P or sublevel. So we have 2P, and then 1, 2, 3. So 2p3. So that's the electron configuration of nitrogen. Now we need to do its orbital notation. So remember the S sublevels, okay, they each have 1 circle. Okay, so the S energy sublevels have 1 circle. The P energy level, or the P sublevel, I'm so sorry, I keep saying the wrong word, has 3 circles. So you would write 3 circles. It has 3 orientations. Each circle represents an orientation. So it has 3 different orientations, and now we're going to fill it up. So we have, in this sublevel, the S sublevel, we have 2 electrons, okay? So you have each electron represented by an arrow. You have to go up and then down. They have to have opposite spins. Then you have the 2s2. So in this sublevel, you have 2 electrons as well. Then in the P sublevel, you have 3 of them, and you have 3 electrons. So do you remember how I told you you have the order that you fill these up is critical? So you can't do 1, 2, and then 3. You cannot do that. You cannot put your second electron here until they're all full, okay? So it goes 1, 2, 3, okay? That's how you would do it. In this case, if it was oxygen, which has 8 electrons, so oxygen would have 2p4, then you would put your second one here. Okay, let's move on to another example. It's probably magnesium. So Hund's rule, you know how I just told you you have to have 1 electron in each circle before you fill the second one? That's Hund's rule. Okay, all of these rules, guys, you do need to know, and they will be matching questions on the test. Okay, so recall if it's elements neutral, the atomic number equals electrons equals protons. So this looks like it's neon. So we're actually identifying elements from electron configuration. So how I do it, how I identify an element is I look at the last 3 things on the electron configuration. So up on the PowerPoint, you'll see that it says 1s2, 2s2, 2p6. So how I like to identify an element based on its electron configuration, I just look at this. So it's 2p, so I know it's not 1, okay, it's 2, and it's not s, so 2p, so it's somewhere here, okay? Sorry, you can't see that. It's somewhere here, and then you just have to look at the number, the superscript number, so it's 2p, so it's somewhere here, and it's 2p6, so 2p1, 2, 3, 4, 5, 6, so the answer is neon. That's how you find how you identify elements from the electron configuration, okay? And then we have sodium, so if it's, if instead of 2p6, it was the same thing, so 1s2, 2s2, 2p6, and then 3s1, I would just take a look at this and just look where 3s1 is, okay? So here's 3, here's S block, and then S1, S2. So we're looking at 3s1, so it's sodium, okay? That's it. So orbital notation is the circle with the arrows. Electron configuration is this. Just the energy levels, sublevels, and number of electrons within. And then by now you should be able to know how to identify elements based on their electron configuration. So again, guys, please post any questions to the forum.